Hello, my name is Prateek Bhatt, and this is my team: Upen yadav, Ritwick awasthi, Manish Kumar verma, Shubham srivastava, and Ajay Devakar. We are from the PinE Training Academy. We are doing a 10-month course on the physical design domain, and we are here to present a project which we have made. So our project is clock tree synthesis debugger, which we have made with the help of the Tickle and TK scripting. So I will let you know what is my project is. I will come to on the introduction portion. So introduction. Firstly, I will let you know what is project. Our project is whenever our CTS log file we get, so user have to read some of the important files regarding the further needs like clock sync and skew target and different files. The user have to read it manually. So we have made a script of that. So user have to use it. It's a very user friendly. User just have to click on that and it can be fetched within a single click. So as you can see that what is a CTS? It is just the stage where in the PD flow we'll get a clock tree in our design with the help of clock buffers and inverter. Basically, it is used to balance the clock in our design. It is also the process of minimize the skew and latency in our design. And what is log file, which we are working? This is the log file only. Log file is a tool generated text file which we get after our flow. Means every flow we will get a log file after every flow. Like if we have completed our CTS, the log file is generated by the tool which shows the history of all the information related to each stage of the PD flow. So I will come on the overview portion. Overview. See, after performing our CTS, the log file which we are getting, it is the information which contains all the information regarding CTS stage, like number of cells added, capacitance, net violation, skew groups, skew target, and different many others information. So it is a very large file. So basically, if a design is huge and a user wants to read all the information, so it is difficult for the user to read all the important information regarding CTS. So there is a need to develop a user-friendly interface which we have thought of that. So for regarding that, we have made up this project and which will show all the important information in easily readable format. So what is the approach of our project? Basically, our approach is depends on this three main steps. Firstly, it will going to read the log file. After reading the log file, it will going to fetch the different data using Tickle script. We have used the regex matching. With the help of regex matching, we are going to fetch the data, and we have merged the Tickle script with the TK. Mainly, we have used this TK for the GUI for getting a graphical user interface. So it will show you in a button like format. It will show you a widget which is in a button format. So it is very helpful for the user. And if you talk about the features of our project, so the features of our project is we have written Tickle and TK script which results in a GUI, which is a graphical user interface, providing all the options to view different types of information. Means if you there is a GUI, so we will get all the information in that or only in the form of menu. We have also provided a menu widget in which all the different options regarding what the information we want, and the help button is also there, and exit button is also there to perform the different tasks. So with the help of help button also, which guides a new user how to use all the features offered in this project. So I will like to come on those modules of which is used in our project. So firstly, when we going to source the project, this menu will going to appear in a button format, which I will going to show you later on after this. So a menu will be displayed on the screen, which will provide options to user for for doing different tasks, and you can see that what is the information we are going to fetch and what is the information is there in the form of buttons. So there is a cell count, capacitance value, net violation, skew group, clock tree, initial summary report, object design summary report, skew target, clock sync gate, and help. And this is a description of every module. What is the cell count? This shows that how many cells are added in the CTS, because when we are going to in the CTS stage, different cells are going to be added. So there is an increase in the number of cells count. So it will show the data in a tabular manner. from the number of cells, area of cell, and also the clock buffers are which clock buffers or inverters which are going to be added. And then the capacitance value. Every wire has their capacitance value also there, and the gate capacitance is also there. So it can be shown with the help of this. And the net violation, it shows the violation type and how many number of net violations and the maximum violations are there. And then we can see the skew group of the CTS also. Skew groups will going to show you the information like insertion delay, min and max, min, because there is a one skew group, and for that group there is a minimum insertion delay will also be there, and a maximum insertion delay is also there, and skew target of that. So we can see that with the help of this script. And then it comes the clock tree CTS. So it shows the information about different types of clock, like these three clock which is in my design is test clock, my clock, and diff clock, which we can see. And their worst trunk slew and the worst leaf slew will also be seen through this. And then the initial summary, because whenever we are going to uh, do do any stage, so initial summary reports we can see with the help of command. And in that summary we are getting the worst negative flag, total negative flag of the violating paths. So this can be seen through this. And it also shows the information about the DRVs are there are three DRVs: max cap, max trans, and max fan out. And DRV is a design rule violation. And then the after optimization, one design summary is also occurs, which also show the worst negative flag what occurs after the optimize, because when it's optimized the worst negative flag will going to be improved and try to minimize as it can be possible. And the TNS is also there, and DRV after the optimization. And there is a one skew target which is set by the ST engineer, which is set provided by the ST engineers, that what are the skew targets we have to take care of that. Then it clock single, because when up in point it shows the how many number of things of a clock is there, and the clock gate for every clock tree. So what is the exact number, we have to see this. So for this we can see we have provided a button and through this which we can see. And the help is basically if any user which is a new user and don't know anything about our project, so it will going to assist the user that how it is working, and it is very helpful for them. And after pressing exit button you can get out of your screen, and it will come out of the script. So, and scope of our project, so it can be used to fetch the information from the long log file, because if design is long, the log files will be going to be long, and it is quite difficult for the user to fetch the information. So it is very helpful for them. And in future we are thinking to implement this script to read the information after every stage. We have made this project after the CTS stage only, but we can implement it after every stage, because every stage some of the information we want, so we have to read it by manually. So if we will made this script for the every stage, so it is very helpful for the user, and it is very user friendly. So now I would like to come on the demo and show it how it is working. So it should be showed by Wish, which is because we have implemented TK in this for the graphical user interface. See, like this, we have made it attractive also. So we have provided a menu with the different attractive colors, which shows all the buttons what we want, like cell count, capacitance value, net violation, skew groups, and different information. And the most important thing, we have given a user to provide his own location, means wherever the file is there he can type the whole location and whole location for getting the information. Suppose a log file of mine is present in the my project directory, so I can source like this. See, I have put the our whole path. What is my path? It is in this project directory. My log file is there. Now I will going to click on we can see in the log file. So it is very helpful because we are showing just by a single click button. So it will showing you the buffers is count is a 424, inverters, clock gates, and the clock logic and all is 462, and the area consumed by them is also shown by this. And now and if you close it, you will get an option that you really want to close. Then you can press yes, then it will be close, and if you press no, then it is be like that only. So I will like to press yes, so it will going to close. Now comes on the second, that is capacitance value, which will going to show you the wire and the gate capacitance and the total capacitance also. It is, and now we can also close it. And there is one more advantage in our project is that we can open a numerous number of files at a single time. Like I would like to show you. See, this is a net violation. What is the number of count of the overflow is it, and the maximum violation by that is, and the count is 3, and the violation is 0.134 ns. And now with the similarly opening this violation browser, I will open clock tree. See, we can open number of files, and it will going to, this is the 3 clock, test clock, my clock, and div clock. And of these 3 clock, the worst trunk sleeve and the worst leaf sleeve is also there. We can see this, and it is a clock tree summary after the CTS stage. So we can see that what is the number coming, and after that initial summary report, in which we are going to see the worst negative flag. It is for the setup mode. For the setup mode, flag is the required minus arrival. So if it is coming in negative, so it means our arrival required time minus arrival time. So our arrival time is more than the required time. So that's why it is coming negative. And worst negative flag means our whole path. This is the path, and the worst negative flag of that path is this much. And with the help, according to that, we can get the DRVs also. DRV is a design rule violation, which is the maximum caps, trans, max fan out, and max length. This is the real one and the total one. And the density can also be seen. What is the density? The density is a 47.239% for the cell. And after this, I would like to close it. Op design summary. See, op design summary is after the optimization operation. So we can see that there's a lot of improvement in the WNS for the all and the reg to reg path and the reg to C path, and the by default. And similarly the DRVs in this was also showing here. And after coming the skew target, which is provided by the ST engineers to us, which is a 0.84. You can see it by a single click. And then the clock sync gate. At a particular sync, how many number of clock gates are going to sync, it is shown here, and the number of clock gates, like 113537 syncs and the 35 clock gates for the test clock. This is the 3 different clock, and it contains 3 different syncs and the clock gates. This is all. And if any new user is there and don't know anything about it, so this help button will going to guide him. Like after opening the help file, it can very helpful for the new user. Like it will show you all the information that what is our project is, and what we are going to fetch, and what is the, it will give you the basic overview of that. So it is helpful for the user. So I will like to close it, and if I going to click on the exit button, then it will going to exit all of close all of my files which are opening in a single go, like you can see. So this is all our project is, and thank you so much.